All right, so example 2, find y. So once again, you notice we have a right angle here. Once I establish what the right angle is, I can establish a leg and a hypotenuse. Always at least mentally do that exercise. You don't have to necessarily write it on the paper, but just make sure you know what the legs are, what the hypotenuse is. So you create the Pythagorean theorem correctly for that problem. So leg squared, which would be y squared, plus other leg squared is 13.8 squared, equals hypotenuse squared, which is 22.3 squared. Okay, these numbers are a little bit more challenging to square in my head, so I'm going to do 13.8 squared. So 13.8 squared and 22.3 squared. Just type it in a calculator, we get those numbers. So I get y squared plus 190.44 is equal to 497.29. Again, use calculators as necessary to calculate things that are not easy to calculate. So I write down what the formula tells me to do, and then I evaluate the things I need to evaluate. Notice I'm trying to get y squared equals, and right now I've got number on this side and number on that side. So the theorem always says leg squared plus leg squared equals hypotenuse squared, but sometimes we have to move to the other side, which creates a subtraction instead of an addition to get what the missing piece is. So 497.29 minus 190.44 gets me y squared equals 306.85. Once you get it down to y squared equals a number, whatever the unknown is, the squared equals a number, you take the square root. To get the answer. So the square root of 306.85 is 17.517 and something. If this were me doing this problem, it didn't specify anything about sig figs, but the fact I have one decimal place, or 3 sig figs, maybe I'm going to go y equals 17.5. Either 3 sig figs or 1 decimal place. Either way, it's the same answer. Okay, again, it didn't specify anything about rounding, so I'm not going to count off the rounding, but just kind of have a reason why you wrote an answer the way it is.